0 and 4, what's the area? Everybody knows that, right? It's just what? 4 times 5, which is 20, right? The area is 20, right? Right? Now let's try this rule. So to do it according to the rule, what do? We have to find the antiderivative, and then we do what? We put in 4, and we put in 0, and we subtract them. So what is the antiderivative? 5x, right? Because the derivative of this is 5, right? Okay? And what do? We put in 4, we put in 0, and we subtract. When we put in 4, what do we get? 20. When we put in 0, what do we get? 0. 20 minus 0 is 20. That's what we think it should be. Okay? So, this is called the integral. Okay? Okay, this is called the integral of the function 5. This is called the integral of the function 5 between 0 and 4. Okay? And it means the area under. Right? It means the area under the function 5 from 0 to 4. Alright? Now, is there any function we can do that would be more interesting? I don't know. What function could be more interesting than what we've done? So this one we could do, we knew the answer. And this one we knew the answer. This one we knew the answer. Okay? And now we already did x squared. Right? What was this area about again? The antiderivative was x cubed over 3, right? So what was the area between 0 and 3? It was 9. So that was slightly interesting. Okay? Now, we could do e to the x. Right? We could find the area under e to the x. Now, I guess one is that's a little more interesting is this one. Do you remember, what is this? This is the cosine of, the sine function. This is the sine of x. So we don't really work with this, right? But you've probably seen this picture, right? The sine of x. And where does this picture come from? So the sine, remember the sine function comes from talking about the angle, right? And we can say, if you go all the way to here, this angle, 90-degree angle, sine is the y coordinate on the unit circle. And the cosine is the x coordinate. So I guess it comes from this picture. We draw a unit circle, which I can't draw very well, and we ask what's the sine of this, or the sine of this, or the sine of 90 degrees. And the sine, you take the points, you just read their y coordinate. That gives you the sine. If you want the cosine, you read the x coordinate. Okay, so like if it's a 0 angle, which means just here, then the height, the y coordinate is what? 0, but the x coordinate is 1. Right, so this is 1 comma 0. Right? So that to get the cosine, you read the x coordinate, and to get the sine, you read the y coordinate. Okay, so the sine of 0, this angle of 0, is 0, but the cosine of the 0 angle is 1. Okay? And then when you go up to 90 degrees, then what are the coordinates of this point? This is a unit circle. Okay, so what are the coordinates of this point? 0, comma, 1. The height is 1, and the x coordinate is 0, right? So remember, the sine is the y coordinate, and the cosine is the x coordinate. So the sine of 90 degrees is the y-coordinate, so that's 1. But the cosine of 90 degrees is the x-coordinate, which is 0. Okay? So that's a review. So this is the sine function because when we start at 0, the sine of 0 is 0, so I started here. The cosine function would be like this, or something, I don't know, something else. Okay? Actually, it would be what? Anyway, I'm not going to worry about it right now. Okay? So let's say that's the sine function. Okay? So suppose I want to know what's the area in here. That might be interesting. So this is, when does the sine get back to 0? So it starts at 0, goes up to 1. Well, it goes up to 1 at pi over 2, or 90 degrees, right? Pi over 2 means 90 degrees. So when we get up to 90 degrees, the height is 1. Right? And then it goes back down at, finally gets to 0 at 180 degrees, or pi. So pi. Okay? So that's this shape. So suppose, right? Isn't that right? Hope so. So suppose I want to know the area there. Okay? So how would I write that question? How would I write that question? I'd say, how do I write the area question? The area of the sine function from where to where? From 0, this is 0, to pi. Right? From 0 to pi, that's kind of interesting. What's the area between there and there, right? Now we don't know how to get the antiderivative of the sine function, right? The whole method is to get the antiderivative, right? And then put in this and put in this and subtract. But we don't know the antiderivative of that. We don't know the derivative of it. We don't know the antiderivative. We didn't talk about it because it's not really relevant to business very much. Okay, it's relevant to other things, but not business. Okay, but it turns out that the derivative of the sine function is the cosine function. Okay, this turns out that way, and it also turns out that the derivative of the cosine function is minus the sine function. So with that, now we know how to do this. Now we know this, because I want the function whose derivative is sine, right? So cosine has what? Its derivative is minus sine, so minus cosine has derivative of sine, right? So now we can do it. So what's the, so what do I have to do? I have to take minus cosine, right? And do what? Put in pi, put in 0, and subtract them. So that's going to be easy. What's pi? So pi is where? It's all the way over here. Okay, what's the x-coordinate of this point? What's the x-coordinate? -1, right? This is -1, comma 0. Right, so what's the x-coordinate? So, so the minus cosine of pi is what? 0, right? Cosine, I'm sorry, -1. 1, sorry. 1. Right? Put in pi, put in 180 degrees. I get -1, but negative cosine gives me 1. Okay, and then what do I have to do? Put in 0 into here, into negative cosine. So 0 is where? There. It didn't work. Did I do something wrong? Why did I use... Okay, that's right. Did I do something wrong? Let's see. Looks like I did something wrong. Pi over 2? Did I draw this wrong? The sine starts at, sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is, sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Okay, I did it right. Okay. Then going back to here, we have the derivative of sine is cosine, the derivative of cosine is minus sine. So I want the antiderivative of sine. So I want the function whose derivative gives me sine. The derivative of cosine is minus sine, so minus cosine. Okay, so it looks right so far. So now what do? I want cosine of pi. So this is pi, so it's negative, negative 1 is 1. And then I want cosine of 0. Cosine of 0 is what?
1.
It's not right. Right, because we get 1 minus 1.
No, 1 plus.
What's wrong? Derivative of that is that. Derivative of cosine minus 9. What's wrong? The antiderivative of function whose derivative is sine is minus cosine. Okay. I think I see what I did wrong. So, let's see, hopefully. So this is minus cosine of 100 of pi over pi. Pi is, minus cosine is negative 1, gives me 1 minus,
Yes.
okay, it's plus 1. Okay? All right? So what's the area? That's pretty weird, right? This area equals 2, I think, if we did everything right. Did I make, is this right? Is it plus 1? Yeah. So that's kind of interesting, right? That the area under this weird curve is 2. Okay? Anyway, I don't know if it's that interesting, but that's one thing, right? Okay, any questions about this? So we've covered now, the word is integral. Okay, so this is read the integral of x squared between 0 and 2. 0 and 3, okay? All right, so we covered that. But except for one thing. I also called this the integral. I called it the antiderivative, but I also called it the integral. Okay? So we have to change our terminology a little bit. So this one is called the definite integral. So this one is called the definite integral, and this one is not called the definite integral. Okay, so the definite integral is when you have, this is an area problem. This is not an area problem. This was an antiderivative problem. Okay, so when we're talking about the area problem, it's called the definite integral. And we're talking about the antiderivative problem, it's called the indefinite integral. Okay, so one is called the definite and the other is called the indefinite. And this one, there's two reasons I think why you could call them, this one called the definite and the other one called indefinite. Two ways to think about it. One is that this is not a single function. What was the answer to this? X cubed over 3, right? But not really. It was that. So there's many answers. So that's one reason why it might be called the indefinite integral, because there's many answers. And another reason is why this might be called the definite integral is because here you get actually a number. when you do this, right? Because this is actually an area, right? So it's a number. Okay? So that's another reason to think of why we call them definite and indefinite. Okay, so we have this concept of the definite integral, and it seems to be related to this. Okay? But they don't naturally have any relationship that we can see. Right? I mean, this is an area problem, and this is an antiderivative problem. Right? So it's kind of ridiculous to use the same notation for them, except that it seems to be that the antiderivative problem solves this problem. Okay? But the reason, or that fact, has a big name. It's called the fundamental theorem of calculus. Because, one reason is, because it relates these two completely different problems. So one is derivatives, and the other is indefinite integrals, or areas. So one is slopes, and one is areas. And it relates these two different unrelated areas of math, right? So it has a big name. It's called the fundamental theorem of calculus. So the fundamental theorem of calculus says that you can do this problem by doing that antiderivative stuff. Okay? So usually we write it like this. Usually they write it like this. Equals x cubed over 3 from x equals 3 to x equals 0. Okay, so that just means I did the antiderivative, and then this means put in 3, this means put in 0 and subtract the 2. Okay, that's what this notation means. Okay? And then they do one more thing, which I really hate this, but they always say that, they always write this. They always use capital F. I hope I have this right. They always use capital F to mean the antiderivative of little f. Okay? So if we do that, I think that's right, then we could do this. Equals what? Using this notation. So we had the antiderivative here, right? Right? So the antiderivative we're calling capital F. So I'll put okay, so if you use capital F to stand for the antiderivative, then you can put it this way. Or they also read it like this. Okay, so that's okay. So that's the notation they usually use, capital F. All right? But anyway, the whole thing is that this is the idea that we found this relationship between two separate parts of mathematics. Two separate parts are what? One is slopes and the other is areas. And this tells me that to find area, you can use slopes or antiderivatives. Right? Okay? So that's called the fundamental theorem of calculus. And now we know how to do definite integrals. Right? Okay. So, what is this question asking? What is that asking? So that's an indefinite integral. Sorry. That's a definite integral. Right, pardon me. That's a definite integral, so it's asking about an area. Right? This is asking about an area. Which area is it asking about? That area, right? Between 0 and 1. It's asking about this area. And then the answer, because of the fundamental theorem, we can use what? The antiderivative of our function. What is the antiderivative of e to the x? That's the easy one. It's just the e to the x, right? Because the derivative of e to the x is e to the x, right? So it's going to be e to the x again between 0 and 1, right? So that's e to the 1 minus e to the 0, right? And then that's as good as we can write, right? E to the 1 is e. Oh, I'm sorry, that's e minus 1. Right? E minus 1. Okay, so the area under here is e minus 1. Okay? Any questions about this? Okay, so we have covered the concept of definite integral. Does anybody have a question about it? Now, the thing is, so if you went further in the subject, okay, so if I asked you this one was super easy, right?